How are you guys? Today, inshallah, we will continue our last lecture about the Anchorage requirement. About the Anchorage requirements. Today, only we will take one practical case for transfer beam to show how to check the Anchorage requirements as per ACI code 318 version 19. The width of this beam is 40 centi by 100 centi or 1 meter, supported by two columns. Two columns are 400 by 400 millimeter, and the planted column is 250 by 1000 millimeter. Um, Concrete cube compressive strength 45 megapascal. So when you convert it to FC prime will be 36, around zero point 0.8 of this value. Yield strength of the steel is 460 megapascal. We need to check the anchorage requirements as per ACI 318 19. This is top view, by the way. Top view for the. This is the reinforcement for the column, supporting columns section. This is transfer beam section, and this is the planted columns section. Sorry, we have only one planted column section uh, as shown in this picture. This is the side view for the system. What we have to check in this case, first of all, this is a planted column supported by this transfer beam, so we have to check that the reinforcement of the planted column should be developed inside the supporting or inside the transfer beam to for two cases. We have to check tension development length and compression development length. Um, and also the top reinforcement for the transfer beam inside the supporting column. We have top reinforcement here. We have to check the standard hook requirement. This is very important. And also the the reinforcement bars for the column should be developed also inside the beam. Use a straight bar development length or 90-degree development length. Also, we have to check the anchorage requirement for the um, dowels of the supporting columns inside the footing. We have to see the depth of the footing is enough to develop the bars in tension and in compression. And also we have additional check here. We have to check the lap splice, by the way, also, but I will not talk about this in this lecture. First of all, we will check uh, anchorage requirements at X. At X, I am talking here about the top reinforcement. Okay. Here you can see I have also some bottom. I will not talk about the bottom reinforcement. By the way, for normal beams, for integrity reinforcement, the ACI code states that for some cases, the bottom reinforcement also should be developed at the support because at the this is as a type of integrity to prevent the progressive collapse or to improve the resisting the progressive collapse. Anyway, we will start with X here, top reinforcement anchorage requirements. Here I am using a standard hook. As we know, the top bar's diameter for the beam is 8 518 millimeter. If we look here, this is the top bars are 580 millimeter. So I need to assume that I need to use a standard hook. So the LDH for the standard hook as per ACI code, it can be found in 25.4.3. This is the equation. I will apply here directly. If we plug the numbers in the equation, we will find that we need LDH 238 millimeter. Before we have discussed about what I mean by LDH. This is the LDH, by the way. This is the LDH. This is the horizontal distance for the bars should be developed inside the supporting elements. So I need here 238, minimum value 150 millimeter. Also, we have minimum value 8 multiplied by the diameter. Anyway, here the LDH will be 238. Okay, but as you can see here, I assume that the modification factors for the LDH all with value equal to 1 as shown here. But I have to make sure that I can satisfy the conditions to use the one value, otherwise the exact value will be more. If we go to this, this is the standard hook that I need to check now. I have LDH, I have diameter for the inside bend, and also I have L extension. The most critical dimension is LDH. L extension, most likely we can satisfy this requirement, and also bend diameter also we can satisfy this easily. But when you go to the modification factors for the standard hook, this, yes, as you can see, in some cases the value should be 1 if you satisfy the condition, same like this confining reinforcement factor. Otherwise you have to use 1.6. So I have used 1. To use 1, I have to make sure that I can satisfy this condition to use 1. Otherwise I have to use 1.6. So for lightweight concrete, the factor will be 1. Epoxy, I don't have epoxy in my case, so the factor also, epoxy factor will be 1. Confinement reinforcement, I assumed 1, but I have to check if I can satisfy the condition, otherwise it should be 1.6. Also location factor, I assumed 1 because I will check if I can satisfy this condition to terminate the bars inside the column core with side normal cover more than or equal to 65 millimeter. If you look here for the location factor, I have assumed 1, but if I couldn't satisfy this condition, I have to use 1.25. So this is very critical when you check the anchorage requirements for the as per ACI code. And also for the concrete strength, in my case the FC prime is equal to 36, so the confinement strength factor will be 0.94. So now before checking the conditions, uh, uh, we have to calculate how much I have distance, the available distance to develop the bars. The column, the supporting column is width is equal to 400 millimeter. Remove the cover. We have a cover here, and also we have stirrups, 10 millimeter stirrups. Remove also the diameter of the main bars, and also definitely you need space minimum 25 millimeter to avoid the concrete segregation. So the clear spacing to develop the bars is equal to 309 millimeter. LDH in my case it was 238 millimeter. You have to take care that I measured the available anchorage length from the face of the column. But for type 2 joints, I mean seismic joints, under the reversal loads, the cover uh, will be damaged, so that this 300 or the actual distance will be lesser than this, because I will measure starting from the ties. So you have to take care about this. Anyway, in our case, we satisfied LDH for the top bars, but I have to check this condition and this condition to see if I am right to use a value equal to 1. Okay, the this condition to for the side cover here, that if I need to use a factor equal to 1 in this equation, the bars should be developed inside the core of the column, and the side cover to the bars should be equal with minimum value 65 millimeter. In this case, if I add the cover plus the ties plus the main diameter for the main bars for the column, I have 72 millimeter. So this condition is satisfied, and I can use location factor equal to 1. This is number one. Now, a second condition that I have to check, um, the confinement. I have used 1. Also, the factor is equal to 1. To use 1, I have to provide here a confinement reinforcement with minimum value equal to 40% of the hooked bars, so that we know that the top bars are 8 bars 18 millimeter diameter, so that the area of the hooked bars I can calculate uh, equal to 2034 square millimeter. Okay, so minimum confinement ties that I need, it should be 40% from this amount or from this quantity, so that 40% is equal to 830 millimeter. If we go back to the reinforcement of the column, as we can see, in each direction we have 1, 2, 3, 4 legs, and the legs or 3 legs ties 10 millimeter diameter at 15 centi. So most of the contractors, what they are doing, they are providing the same ties at the same distance through the joints, through the column beam joints. But in our case, we have to make sure that at 15 centi spacing is enough or no. So if I need to provide the same ties type as a number of legs and diameter, so I have to reduce the spacing from 15 centimeter to 9 centimeter to reach this amount of steel of confinement, so that at the area of the top bars, or where I need to develop the top bars, I have to add minimum 3 ties with 10 millimeter diameter, and each tie has 4 legs with the same diameter. So without providing these ties, I cannot assume this factor is equal to 1. This is very, very important. And also we have maximum spacing between stirrups shall not exceed 8 diameter of the bar. So already we are providing around 90 millimeter spacing. Also, if I need to use 100 millimeter, also it would be acceptable. And also the stirrups shall be provided within the distance not exceeded the 15 the diameter. This picture can be found in ACI code, by the way. Uh, uh, as I have said that the ties, additional ties, should be with the distance 15 diameter. This is very important. So if you don't provide these ties, the confinement factor will equal to 1.6. In this case, the LDH, or the minimum horizontal length of the top bars will be 380 millimeter, which is more than the available distance. Here we have calculated the available distance, so that in this case, not okay, not satisfied, and you have to reduce the bars diameter, or you have to increase the column width. In this case, we shall reduce the bar diameter or increase the column dimensions or use other type of anchorage. Assumptions shall be shown as a structural details in your drawings, definitely. Also, check tail extension and bend diameter. I am talking about the L extension. L extension is equal to a 12 diameter of the bar for 90-degree hook. Anyway, we have enough depth in our transfer beam, so I'm not worried about that. And the 90-degree bend, also we have minimum diameter. Diameter was 18 millimeters, so we are here. So the minimum inside bend should be 6 multiplied by the diameter of the bar. So 6 multiplied by 18 millimeter. This will be the minimum bend diameter at this area. Because we said before that the minimum bend or inside bend diameter is very important to satisfy the bearing stress at this area. Now we can check anchorage length at point Y. I'm talking about this. In this area, don't waste your time for the modification factors, and you can assume the extreme case. So I will assume as a conservative assumption that all factors will be with the maximum. So LDH in this case, how much will be? 426 millimeter. Here the bar is 16 because the transfer column bar, uh, all bars were 16 millimeter in diameter, so that the LDH will be 426. Anyway, we have here enough distance to develop this bar. Also, if you would like to check the straight development length, it's up to you, by the way, but you have to satisfy straight bar or at least a standard hook 90-degree or 180-degree. And also we have to check the same bar but under compression development length. Also under compression development length, we can use the equation in ACI code. So I need minimum distance LDC equal to 294 millimeter. This is very important. So the beam depth is enough to develop the bars for tension and compression forces. Okay. At point F, this is very important inside the footing. Uh, we said before also that the minimum anchorage requirements may govern the depth of the footing, not to a shear only. So here we have also 16 millimeter diameter for the column. So LDC we can apply this straightforward. So I need minimum LDC 294 also millimeter, and this is the minimum LDC 317 millimeter. Footing depth is equal to 55 centi or 550 millimeter. So I need to check the available anchorage depth or anchorage distance. So the depth of the footing minus the cover minus I have two layers of reinforcement at the bottom bars 16 millimeter. So I am talking about 443 millimeter, and what I need 317 millimeter. So also satisfied. Also, I have to check the same bars for the tension. Most of the engineers they are thinking that columns only are subjected to axial or compression force only. No, sometimes small unbalanced moment will result in tension in your columns, and in this case you have to use the you have to check the tension anchorage. So always I prefer to check both compression and tension anchorage requirements. I also have assumed the extreme case here for the confinement, for the modification factors 1.6, 1.251, and the LDH is equal to 426 millimeter, which is not okay. At this case, don't increase the depth of the footing. We have to check the conditions of these factors again. Um, so modification factors shall be revised again. Side cover, side cover. Definitely, this is continuous raft foundation. So the side cover will be more than 6 diameter for the bar, so that the location factor can be assumed 1 instead of 1.25. So again, you can make recalculation uh, for the LDH again using 1.25, and also concrete factor also can be 0.94, because in our case the FC prime is equal to 36 megapascal, so the LDH how much is equal to 320 millimeter. So for the most of cases first trial, I am assuming the most conservative solution. After that, I am coming back to make revision for the or to revise the modification factors. Also for Z, we know that the depth of the transfer beam is more than enough to check to develop the bars in compression and in tension. But if you have a problem, you can use additional confinement ties to reduce the required tension length. Also, you have to know that in case of intermediate moment frame system, LDH or the minimum LDH equation is different than ordinary system. So you have to check the LDH for the ordinary and LDH for the intermediate moment frame system. Then you have to take the larger between them. And also, as we have said that when you need to calculate the available anchorage distance, you have to measure that from the ties, not from the face of the column. This is very important. Also, in our case, if we need to calculate the anchorage distance or LDH using the intermediate moment frame equation, also we can find that this condition is satisfied also. Uh, some engineers before, they were asking me about I have to turn these bars outside or inside. Anyway, normally outside is acceptable, but for special elements or special moment resisting frame, this, by the way, this provision from ACI 350 environmental structures, but also I believe it can be found also in ACI 318. But this is for special moment resisting frame, not for ordinary. Here ACI 350 states that um, longitudinal reinforcement resisting flexure shall have 90-degree hooks near the bottom of the foundation with the free end of the bars oriented toward the center of the column. This is preferred more, and I have seen, by the way, both outside turn outside and turn toward the center, but this is preferred more, especially for the special moment resisting frame. This book is very useful if you'd like to see also additional examples uh, about how to find the development links for straight bars. I will only show this quickly so engineers they can take a look. I hope that the lecture today is useful for the structural engineers, and I hope that we can make other discussion for other structural topics later.